Well friends, today we will do some couple of problems with reference to Gauss law. Let us see and try to understand how we can solve the problems with this theorem. Suppose our first problem is like this. Suppose you have two non-conducting sheets. This sheet is having positive charge density and this sheet is having minus charge density. Let us see, suppose this is having sigma, that is the charge density is equal to 7 microcoulomb per meter square, and this is having sigma minus 4 microcoulomb per meter square. This is the charge density on these two non-conducting sheets. So we have to find out electric field at the left, electric field in the middle, and electric field in the right side of these plates. So our question is, what is EL, that is in the middle, and ER, that is on the right side. Now, for solving this, let us make use of the Gauss law. It is a positive sheet, so naturally electric field due to this, suppose this is sigma 1 and this is sigma 2. So this is E1. This electric field will be in this direction because it is plus. Now let us see, due to this sigma 1 in the middle, it will be in this direction. From positive to negative. Any problem? Now on the right side, due to this sigma 1, again it will be in the right direction. Correct? Now, due to the sigma 2 minus side, minus sheet, what will be the direction? It will be correct. Here it will be and due to this, here it will be in this direction. So these are the directions of the electric field due to the charge density sigma 1 and sigma 2. So what is basically E1? E1 we can calculate this is for a non-conducting sheet, it is sigma upon 2 epsilon G. Correct? So this will become your 7 microcoulomb per meter square upon 2 into 8.85 into 10 raised to minus 12. Coulomb square upon Newton meter square. You have to take care of the units. So this will be the electric field E1, and this will come as your 4 into 10 raised to 5 Newton per coulomb. Likewise, if you calculate E2, by putting these values, it will come as 2.25 into 10 raised to 5. Correct? Now we can calculate what is EM. Here, E1 is in this direction and E2 is in this direction. That means this will be nothing but 4 minus 2.25 into 10 raised to 5 Newton. Correct? What will be in the middle? These two directions are same. That means here it will be right, and naturally in the right it will be again 4 minus into 10 raised to. So this is your basically answer, and this is how you can analyze this problem. Now you can see, suppose these two things are same, then this will be 0. That means electric field in this direction and in this side and in this side, it will be 0, and there will be only electric field in between the plates. Now we will switch over to our next problem. Our second problem is like this. You have two non-conducting plates. Here it is sigma plus, and here it is sigma minus. And you are given an electron in between the plates, and you are given three situations. Situation number one, your sigma plus is plus 6 sigma, sigma minus is minus 2 sigma, and distance between the plates, it is d. In the next situation, it is plus 4 minus 4, and now the distance is 2d. In the third situation, it is plus 3, it is minus 5, and the distance between the plates is 3d. You have to find out acceleration. On electron. And categorize them from maximum to minimum. Means in which case acceleration on the electron will be maximum and where it will be minimum. So naturally there will be electric field and due to this electric field, suppose this is E, then it will experience E into E. This will experience a force of E into E, and the acceleration will be F upon m, and you know the mass of the electron, you can find out the acceleration like this. But let us see what is going to happen in all these three situations. As in the previous problem, we have seen in this region between the plates, this charges are added up. And due to this, in this situation, this will be 8 sigma. Here also, this will be 8 sigma, and here also, this will be 8 sigma. How this is going to happen? Please, just previous problem you can refer. So electric field will depend on the summation of charges, because they will have this minus and plus, they will have the electric field in this direction only, in between the plates. So that means electric field in all these three situations will be same, because in the last problem we have seen electric field does not depend on this distance also. And here also the distance is not in the question, or it is not affecting in any way. It is not, force is not dependent on the distance between the plates. Acceleration is not dependent on the distance between the plates. And because all these three charges, they are adding up, so electric field in all the three situations will be equal. Electric field E will be equal in all three situations. Correct? Now, since E is same in all these situations, what is remaining? That means acceleration will be same in all three situations. So this type of question can come as a multiple choice question also. So don't confuse yourself if distance is given or charges are different like this. So that's why I took up the numerical problem in the first question and showed you how this electric field will be the summation of these two charges appearing on these two non-conducting sheets. So I hope this is clear. Please don't commit any mistake. Be your concepts clear on this issue. So now we will go to the next problem. Now let us go to our third problem. Let us see problem first. You have two insulated spheres. These are insulated spheres. Correct? Well, they are basically at a large distance and both are having same charge. Correct? Now, suppose these two spheres are brought together and then again they are brought in the same distance, like they are touched, and after this they are again at the same distance. Suppose this is R and then again it is R. So these two insulated spheres, they are brought to each other, they are touched and they are again moved back to their original position. So now what is the question basically? Question is, suppose they are experiencing a force F here and now they are experiencing a force F dash, then find the ratio of F divided by F. What was the force between them earlier, and now what will be the force between them, and we have to find out the ratio of these two forces. Here F, you know, what will be F? K Q square upon R square. But here, now since they are touched, and then there will be, suppose after touching and their charges are Q1 and Q2, then naturally F dash will be K Q1 Q2 upon R square. Correct? But we have to solve the problem within the parameters, like we are given only R1 and R2. So, and of course Q. We don't know what is Q1, what is Q2. So, how to find out the ratio? Now, here, what will be Q1 plus Q2? This will be nothing but conservation of charges. That is, this will be nothing but, this will be equal to 2Q. Here it is Q and here it is Q, 2Q. This will be redistributed, and this will be Q1, Q2 will be this conservation of charges. Now, but with this equation, we cannot solve this problem. So another equation we need. So what is happening more? Now once they are touching, then what will happen? Their potential, electric potential, it will be redistributed and become equal. This is what you have to understand, because their potential, once they are touching, their potential from higher potential to lower potential, things will redistribute, and ultimately the potential will be same. Must be equal to K Q2 upon R2. Sorry, this is R1. What will be the potential on this sphere? Q1 upon R1, and here R2. Correct? That means Q2 is nothing but R2 into Q1 upon R1. If we put this value here, then Q1 plus R2 Q1 upon R1 must be equal to 2Q, or Q1 will be nothing but your 2Q upon this will become, sorry, this is R2, Q2 is R, Q2 is R2, this is Q1 plus Q2 is nothing but R2, this is R1, this is R2 upon Q1 upon R1. So this will be R1 plus R2. Here it will come R1 plus R2, and here it will come as R1. Likewise, your Q2 will be nothing but 2Q R2 upon R1 plus R2. It is just simple mathematics. Now Q1 and Q2 we can substitute here. So what will be the, basically we have to find out the ratio. This will be KR1, KR square, KR. This will cancel out. Q1 and this will become 2 4Q square R1 into R2, and this will be R1 plus R2, correct? Ultimately, this is nothing but your R1 plus R2 whole square upon 4 R1 R2. So this ratio depends only on this. So this can be, you can be given only the radius, and you can be asked this problem. You can be asked this ratio. So don't panic, because after all it depends on, this ratio depends only on the radius of the spheres. Now you see, if R1 and R2 both are equal, then forces will be same, because then due to this charges will be same, because potential will be same on this, and there will be no redistribution of potential, and charges will remain same on each sphere once they touch and taken back. So this was a very good problem. It has appeared in the competitive exams. So just make a note of this. Now we will go to the next problem. Now let us go to the next question. Suppose you have a charged wire. This is sigma, this is lambda, and here the charge is plus. Lambda is nothing but charge per unit length. Correct? You have another wire. Here it is minus, it is lambda 1, it is lambda 2. Suppose this is L, this is the origin we have to find out where on this x-axis where the electric field will be 0. Here again we can draw the electric fields like this E1, E2, this is E1, this is E2, and here E1 and this is E2. Electric field cannot be 0 in this portion because both are adding up. Here, suppose lambda 1 is more, then this component will be more, and since this is originating from here, because what is the electric field in a charge wire? That is lambda upon 2 pi here. As the x increases, electric field decreases. But this component is more, so here, and this is less because it is at a distance. So naturally, in this portion, also the only portion which we are having is this portion. Suppose this, at P, suppose this electric field is 0. This P distance is x, and this is nothing but this will be your L by 2 and L by 2. Correct? So now since electric field is 0, here what is x? Here the x will be your x plus L by 2, and here x minus L by 2. We can equate this thing as 0, and if you simplify this, then x will come as lambda 1 minus lambda 2, lambda 1 plus lambda 2, L by 2. So this is the x value. Let us take the numerical problem. Suppose lambda 1 is plus 6 micro coulomb per meter and lambda 2 is minus 2 micro coulomb per meter, and your L is nothing but 8 centimeter. Then let the photos, it will be more clear from this. Here lambda 1 is 6 micro coulomb per meter minus, this is minus 2 micro coulomb per meter and divided by 6 into 8 centimeter means 8 centimeter divided by 2. Here it is, this will become 8 and this will become, sorry, this will become minus, because if you put the correct signs, then this will be nothing but 2 into 8 by 2 centimeter or 8 centimeter x. That means this is your 8 centimeter, or we can say this is from this plate, it will be 4 centimeter. So do this, with this numerical we must have understood, because I have not taken the sign, it is plus a plus only here. Since I have not taken here the signs, we have to put the correct sign in the equation, then only you will get the. So these were some of the problems pertaining to Gauss law and our electrostatic chapter. So in the next video we will be doing some more problems like this. These problems are very good, go through it, and these problems, on this pattern only the problems are asked in the exams. So please, if you like this video, please do subscribe my channel, and thanks for now. Thank you very much.